Before I continue, really, I just want to make a note following on from Christian and Corbus's presentation on T4D. It's quite evident that it's a very comprehensive software solution with a lot of very powerful features. And if any of this is of interest to anyone on the webinar, and would like to look at getting a trial going or anything of that nature, or chatting about it in more detail, please just get in touch and we'd be happy to chat with you further on it. So just to carry on about the OPTRON's monitoring portfolio, we recognize that every site, every mine, every project is unique in a lot of with a lot of different features that go on with these operations. So with that in mind, OPTRON have developed our own in-house engineering team, and we are able to offer a bespoke monitoring solution depending on what's going on your particular mine. I'm going to go through a few examples of what we've developed and what's available from us. Aside from just setting up a total station to record prism monitoring automatically, there's no point in setting it up if it's not going to be adequately protected. So we've designed a monitoring enclosure. It houses the total station over the pillar, but inside this enclosure, we've included things like backup power solution, so you'll have uninterrupted monitoring, regardless of whether the power is available or not. Obviously, with a finite period of time available, but with sufficient time to remedy the fixed power solution. We can even connect up solar power as well. So if you want to be completely autonomous, also housed within there is all the communication system, broadcasting the readings wirelessly back to a central location. And due to the nature of active mining, there's always fly rock that can damage structures that are installed right at the pit edge. So we have a very robust blast cage which we place around the enclosure. Where there's not a requirement for a blast cage, then obviously we won't put one in. And the image in the middle is an example of our radar enclosure. I'll chat about radars in a second. But inside the middle image on the left is a radar with a solar panel solution on top, and a total station is housed on the right-hand side there. The protective system we have on the right-hand side image was designed for a dam monitoring solution, and we have installed a few of these on dam monitoring sites, but they have also been adapted for mining monitoring as well. There's been some mines where it hasn't been possible to place an enclosure like the one we've got on the left, just due to space and access. And with no blasting going on in that particular area, it makes sense to install a more slimline protection system, such as the one demonstrated there. And then housed in the stainless steel boxes adjacent to it is the associated electronics and the communication system and backup power solution. So you still have the same backup power system as you have in the main enclosure, just in a more compact form. And as I said, although this presentation is very much geared towards the mining environment, and that's the whole topic, a lot of these can be adapted. So if there's any viewers of this webinar that aren't directly involved in mining, perhaps you can see some application here for projects or challenges that you have that are non-mining related. This could be dam monitoring, it could be buildings, could be civil engineering sites, etc. So OPTRON are official providers of IDS radar, ground-based radar monitoring solutions. The three main radars that we're able to provide are the IBIS ArcSAR, the IBIS FM, and the Hydra X. And I'll give you a quick introduction into each of these three separate radars. The ArcSAR is a 360-degree long-range trailer-based, so it's mobile radar monitoring solution. This is an incredibly powerful radar. It has a 3D radar sensor mounted onto an arm, which can swivel around, taking measurements in a full 360-degree arc. It's low profile, only has one moving part effectively, and has a panoramic camera attached to it, and has an integrated solution for power, a backup generator, solar, etc. And with it being mobile, you can literally park it wherever you need radar monitoring. So some of the key aspects of this radar, you can scan 360-degree view. The range can be up to 5 kilometers, so really short range to long range scanning capability available. Because of the 360 ability, scanning ability, you can get a fast scan within 40 seconds. So it's really excellent for high precision, rapid monitoring in sensitive areas. But that doesn't mean that it's only suited for rapid monitoring. You can place it in a static environment where it will measure continuously. So it's very useful for long range and long-term tactical monitoring, where you're looking for movement trends over a prolonged period of time. Being trailer-based makes it really quick and easy to deploy. And I mentioned the power, various power solutions available. You can, of course, hook it up to a permanent power solution, but there is power available via the onboard the trailer. Moving on to the FM, this is the original synthetic aperture radar solution from IDS. Here is one just installed outside in its barest system. It is weatherproof. It can handle a mining environment. But when you are installing this adjacent to blasting activity, we do encourage installing them inside enclosures with blast cage protection. An excellent workhorse, extremely reliable, long range, over 4 kilometers, and really well suited for long-term static monitoring, where you don't need to relocate the radar regularly. And excellent long-term data and movement trends from this type of radar. And then IDS, this is a fairly recent development from them. It's been out for a couple of years. The Hydra X is based on the ArcSAR technology, so the radar sensor head at the top rotates. It doesn't rotate a full 360-degree arc. I think it's 120 or 160 degrees. It's designed for rapid deployment in critical zones. So it's a close range monitoring, radar monitoring solution with a range of up to 800 meters. And it can be adapted for underground applications. So if you require radar monitoring in an underground mine, where you need to understand if there's any ground or movement of the tunnels going on, this is an excellent solution for that. A quick overview of the solution. It is tripod-based. It comes with a camera on the front. Being tripod-based means you can deploy it anywhere. You don't have to necessarily have a stable concrete platform. As long as the ground's stable, you can level it with a tripod and you're good to go. The whole system can be carried by 2 people. The power and control unit comes in a separate enclosure, which is transportable, and that houses the battery and the communication system to drive the unit. It works on exactly the same technology as the ArcSAR with the swiveling head, and the data feed goes into the same comprehensive Guardian software suite, which is used to control the main radar units, so with the ArcSAR and the FM, so you don't lose any of the functionality there. So it's an excellent tool in that regard. So now we leave the ground now and we go into the sky. Same technology, radar, the utilization of radar imagery, but satellite-based. So satellite InSAR is satellite interferometry using synthetic aperture radar. So the way it works is there are a number of constellations of radar satellites orbiting the Earth in a fixed orbit, in a north-south orbit to be specific. There are certain constellations that are actually recording data as we speak. So they are there's a library of imagery available, which is very useful for doing historical analysis, and it's an excellent tool for trialing this method of monitoring to see if it's useful over your mine. There's data going back until 2017. So with the radar imagery that's stacked, you can actually get a movement profile, and I'll show some examples of what it looks like. You can literally get down to millimeter accuracy with this technology. And being satellite-based, you can cover very large areas, which is ideally suited for mines, considering the size of the operations. Depending on the satellite, you can get resolution actually down to 1 meter, which is quite specialized, but generally we say the higher resolution is in the order of 3 meter pixel size on the ground. And the historical data, as I mentioned in point 1, that's typically around about 15 to 20 meters pixel size on the ground. These radars, these satellites acquire new images every 8 to 11 days, depending on the constellation, which means you get a new image over the same area at this time period. So you shouldn't really view this technology as a rapid monitoring tool. It's more of a background monitoring solution that gives you excellent overview of where potential movements may be occurring. So it's a long-term monitoring strategy that you utilize with this. I'll give you some examples of how this technology is used effectively in a mining environment. Here we have a particular pixel that we've pulled out of the data. It's on a waste pile, and we've got a number of years worth, 2 years worth of data on the screen here, and each dot represents an image back into a radar image that's been acquired, with all the imagery being stacked and a movement profile is calculated. You get to see an excellent displacement trend of these points that have been calculated. So as I mentioned, you can determine quite a high degree of precision down to millimeter of vertical and also east-west displacement. I'll come on to the east-west or horizontal displacement in a second, but I'll focus on the vertical displacement for now. What you're seeing in this image is some hotspots that denotes settlement. So where we're seeing settlement is related mainly to waste piles and slime dams, which are settling on this particular mining operation. Green points indicate where no movement is occurring, which is good. But where you're seeing some purple coloration, that denotes areas of change. Now, with the nature of radar data, and the same limitation applies to ground-based radar, where a dramatic amount of movement or dramatic amount of change in the ground has occurred, the radar has nothing to compare to. It's outside of the frequency band, and it records change, but obviously not the scale of change involved. But it's still a useful feature because you can use this data to see where areas of change have occurred, and they may be in line with, say, mining activity, where active mining is occurring. That's exactly where you'd expect these purple areas to come up. But it could also highlight areas where you don't expect change to occur. This could be linked to standing water. It could be linked to a waste pile that's not supposed to be added to, but it has been added to, or it could even be linked to illegal mining activity that's occurring in the area. And it allows the mine to then use this data set to go out into the field and then look at those areas on the ground, just to see if they correlate to the data that they're seeing from this reporting. So as I mentioned, there's east-west movement, vector movement that can also be pulled out of this data, and that's because you can combine two radar images in what's called the ascending geometry and descending geometry. And you can extract east-west displacement because the satellite is moving in a north-south orbit. The downside to that is you can't extract any north-south movement vectors. But the east-west movement is particularly useful in determining if there's any movement occurring around your pit, outside of the pit perhaps, or on waste piles where there might be some horizontal movement going on, and particularly useful around tailings facilities where the tailing structure might be undergoing some horizontal movement. And it's a good way to also find if there's any horizontal movement where you may not necessarily be picking up any vertical movement. And so it's a useful correlation tool. Again, the purple hatched areas we're seeing here is the same reason for on the previous slide, just relating to areas of change. So with these east, west, and north, south, east, west, and vertical vectors that we can generate this data from, you can overlay this data onto a DTM and you can do cross sections, and it becomes useful in doing analysis on how things like waste piles are behaving. This is an example of a cross section through a waste pile, and you can see the vector movement there of how the waste pile is settling, but also with a horizontal component to that settlement. And where it becomes particularly useful, this is a cross section through a pit. Now, normally it's quite difficult to monitor the base of a pit due to the ongoing activity within the mine. You can't place a prism down there or any other sensor. Generally will become obstructed or destroyed by the activity that's going on. But where you've got, in this case, we're actually seeing some points that were picked up from the InSAR, the satellite InSAR monitoring results, where there's heave in the base of the pit. And this heave is because of the uplift of the ground as a result of the mining activity, and it's generally expected, but this gives a quantifiable result, which the engineers on the mine can correlate to their design to ensure that this movement is meeting their predictions. As I mentioned, where this becomes quite useful is ground-based monitoring is generally always in place in an active pit mining operation, be it prisms or ground-based radars, but they're generally focused on the pit itself. Where satellite InSAR becomes particularly useful is understanding what's happening not only in the pit, because you will get some results from the pit where there's no shadows, but you can also see what's happening around the pit where there traditionally isn't any monitoring. And in this case, a 20 millimeter horizontal movement contour has been calculated, showing that there's actually movement occurring outside of the pit. And it's very useful for the mine to then understand that there is this creep that's going on outside, and there may be an impact on plant at a future date. So they could install either further ground-based monitoring points in this area or put in some mitigating solutions to prevent any further movement. So we've come to the end of the presentation for me. I hope we've demonstrated in this webinar that OPTRON has a very comprehensive portfolio of monitoring solutions, and these solutions are tried and tested in a mining environment. And as I said at the start of this presentation, that each of the sites and each of the projects are unique, and they have their own challenges. So this is where OPTRON can sit down with you, and we can help you design an appropriate solution that meets all of your requirements. And I conclude on that. Thank you.